back over our exponent rules. So if I have the same base, I combine my exponents like this. If I have a power to a power, I multiply my exponents. If I have roots that have matching exponents, I can combine them all under one radical, right? Then what we do, oh, this is that one that you were looking at, right, Angie? So on this one, I can distribute, there's parentheses, I can distribute the m to everything in. But it was a little bit more complicated because we had something else, right? We had like a b. Then it would be a to the m, b to the m, or a to the b to the mn. Ooh, look at that. Okay. All right. We talked about the index. We didn't really look at that graphic that much. More exponent rules. Those are the same ones? Nope, distributing this way. Same type of idea, right? This one, if I've got something that's rational, I can distribute the exponent to everybody. And then I'm going to do this one. What if I had x to the 6 over x squared? I could rewrite that 2, 3, 4, 5, 6 over two in the top, and the numerator and in the denominator cancel out, and I'm left with x to the 4th. I'm taking off, if I have 2 in the denominator, what I'm actually doing is taking off 2 in the numerator. Right? Sorry. I'm going to show you why right now. Is that what we're doing? I'm subtracting 2. X to the 6 minus 2, which is x to the 4. I'm going to show you why that works right now. Well, you can see why it works, right? If I've got 2 in the denominator, it's really just like subtracting 2 from the numerator, right? I know you have, but I'm just reminding. You're welcome. Okay, so if I have something in the denominator with this whole idea, what if I had this? Couldn't I rewrite it like this? Why not? Isn't that what I did here? When I put the x squared in the numerator, it became x to the negative 2. Okay. Doesn't matter. When it's negative, it's all by itself. So look at, even if I have something up here, if I had x to the 4th, then it would be x to the 4th minus x cubed, which is just x. So we're going to use this notion of negative exponents, and I'm going to show you why it works right now. Okay? What? All right, so this is discovering negative exponents. So take a look at this from the top to the bottom. Can you tell me what I'm doing on the yellow side? I'm going down. Sydney? Going to decimals. So from here to here, I said to myself, I think I'm going to go to decimals. You see what I mean? Eventually we're going to go to decimals, but how did I get from here to here? I love it. You guys, somebody in last class said I took a 0 away. I ate a cookie. How do I take a 10 away? I divided by 10. It was Sarah. I divided by 10. I divided by 10. I divided by 10. So what do you think I'm going to do now? I'm going to divide by 10. And then I'm going to divide by 10. and then I'm going to divide by 10. Okay, now check this out. I could rewrite this as 1 over 10 to the first power, 1 over 10 to the second power, 1 over 10 to the third power. Couldn't I? Well, do you see that this here matches this, only the exponent is negative? It doesn't matter what the decimal is. So if I saw this, you guys, what would this mean? Hold on. If I saw this, 10 to the negative 4, how could I rewrite that? 1 over 10 to the what? Positive 4. I don't want you to look at it that way because that's only with base 10. I want you to look at it, if you see a negative exponent, negative exponents are positive fractions. Yes. But what if I see this? What if I saw this? What would this mean to you? 10 to the 5th. Yes. That's what that means. These two expressions are equivalent. Okay? So whenever you see a negative exponent, it's the inverse, right? The multiplicative inverse. Are you ready? You guys are looking at me like, this is old news. Last period was not like that. Okay. I don't think I presented it quite as well, though. Okay. Alrighty. So, last day of exponent rules. If I have a negative exponent, it's a positive fraction. If I have a negative fraction, it's a positive exponent, just inverses. And this is the same idea, right? If I have something positive in the denominator, if I bring it into the numerator, I can make it a negative, and then I can combine exponents. So we're going to use this now. All right, so everybody pencils down. I'm going to go ahead and simplify this, and then you guys are going to write it in your notes, and then you're going to try the next one. All right, so always, always, always you want to factor. So let me write my fraction first here. So I see 18, and I say to myself, I've got an 18 and a 10. They both have a 2 in common. So I'm going to factor this 9 times 2 and 5 times 2. I have an x to the negative 3, and I have x to the negative 1. I could put the x to the negative 1 in the numerator and bring that one down here. But then I would have to still manipulate exponents. So if I bring the x to the negative 3 down here, I'm just going to leave it down here with the negative 1, because I'm going to combine exponents. Makes it a little bit easier. So I'm going to bring, I've already got x to the negative 1. I'm going to bring the x to the negative 3 down, the denominator, and it's going to be positive. Do you guys see how 3 of them minus 1 of them is going to make 2 of them? If I would have put the x up here, then I would have had to bring it back down and subtract. Then I have w squared 4 times. W, I'm going to say it just like I'm reading it. I've got w, I should write it just exactly how I'm saying it. I've got w squared 4 times. Then I have a z to the 11th and a z to the negative 1. I'm going to leave that z to the 11th there, right, because it's already positive. And bring the z to the negative 1 down in the denominator. Z is a positive 1. Are we all good? So take a look at it. What did I forget? The w to the negative 5. The w negative 5 needs to come up in the numerator as a positive 5. Better? Take a look at it. I want it to end up, our goal is to make all of our exponents positive. I'm not done. I'm not done yet. Okay, are we good? Can I move on? Okay, so these two cancel. These two I'm going to combine. These two I'm going to combine. Yeah. This is going to become 8, and then I'll combine these two. It's the same variable. It's like saying I have 8 W's and 5 W's makes a total of, right? Okay, so my 9 is just going to stay there. My 5, I can't simplify those anymore. I have a total of, this is an 8, and an 8 and a 5 make, I just lost my pen. Every day, same time. W to the 13, and x to the 2nd power, and z to the 12th power. I didn't change my color. Z to the 12th. Thumbs up, thumbs down. How are we doing? Okay, so either take a picture of it or copy it down, and we'll do another one. Okay, can you guys do this one on your own, or do you want me to, why don't you guys try and do it on your own? Okay, you guys try it. Okay, so I think I'm going to rewrite the radical to be a 1/4, but I'm not going to do anything on the end. I'm not going to distribute it yet. I'm just going to leave it like this. That means the same thing as √4, right? Do you have to do that first? No, it doesn't have to happen that way. Okay. All right. Okay, next I'm going to look at these 2's. I've got a 2, I've got a 2 times 16. I'm going to look at the x's. I've got the x's, the 7th power in the bottom. That one, the denominator, that one is bigger than this one, so I'm going to leave it there. X to the 7, and then I'm going to move x to the -1 down in the denominator for x to the 1. I've got w to the 5th in the numerator. That's bigger than w to the 1st, so I'm going to move the w to the 1st and make it negative. So that's that to begin with. Then I say to myself, this simplifies to a 1. These are going to combine. And these are going to combine. So now I'm going to rewrite it, still all to the 4th. And I'm left with w to the 4th and 16 x to the 5th. Sorry, 8. 7 and 1 make 8. This became negative when it came up to the numerator. Yes, you move the smaller one. Yes. We are right now. I'm not done yet. Okay. So now I'm going to distribute. I'm actually going to, I might as well change this right now to 2 to the 4th. Because when I distribute, it's going to distribute relentlessly. So now I'm going to distribute everybody. It's going to get a 4th. So w to the 4th is going to get times 1/4. 2 to the 4th is going to get a 1/4. And x to the 8th is going to get a 1/4. You guys see that I distributed the 1/4 to everybody? Everybody got one? So now the 4's cancel here, the 4's cancel here, the 8's cancel, and I'm left with the 2. So this should be my final. W over 2x squared. Sure, we're gonna do quite a few more. Ready? Anybody want to take a picture? You can take as many mental pictures as you want. pictures are being taken. 1 second. We are going to start on your homework. Get it? Okay. You don't get this? But that wasn't as funny as I thought it was going to be. Okay. It means I. Does. Yeah. Okay. All right. There's 2 ways to look at this one. Okay. You guys get why I put the pictures up, right? Because this is incredibly dry information, so it gives us something to like break. Oh, there you go. Look at that. Okay, so when you have a negative exponent on the outside, there's so many different ways I could do this. Okay? I could distribute the negative 1/4. I think I'm going to work that way. All right, so if I distribute the negative 1/4, I would have 5 to the 4. Let's give it some color. Negative 1/4. 5 times negative 1/4 over 10 to the 4 times. We could do it that way, right? You like it? It's distributing a negative 1/4 to everybody. I'm going to do it this long way, and then we're going to do it a shorter way. Then these would cancel, and I just have a negative 1, and these would cancel, and I have a negative 1. So it would be 5 to the negative 1 over 10 to the negative 1. Then since they're negative exponents, we could switch them. And 10 divided by 5 is just 2. You want an easier way to do it? I could have, from the very beginning, let's take this, from the very get-go, I could have said 5 over 10 to the 4th times negative 1/4, which is 5/10 to the negative 1, that means everything's going to switch, right? If both of them have negative exponents. Which is just 2. Or, there's all kinds of ways you could do it. Or, I could have done it this way, guys. From the very beginning, I could have just switched them, and that would have become positive. 10/4 over 5/4 to the positive 1/4. Do you see how all of them are the same thing? I'm doing basically the same thing on every single one of them. Tedious. So whenever you see a negative on the outside of everything, you could just take and switch everything on the inside. Okay, that's probably the easiest way to do it. All right, let's try another one. Let's try the one under the heart. Can you do that? You guys practice that one for a second. Come on. All right, guys, this is how I would do this one. Since the 2 is negative 4, Stina, I would put it in the denominator as 2 to the positive 4. Since the 4 is negative, I'm going to put it in the numerator and make it positive. Right? 32, since I have a 2 here, why can't we make everybody 2? Isn't 32 really 2 to the 5th? But I have 2 of those. Right? And down here, what's 16? 16 is 2 to the what? 2 to the 4th, and how many of those do I have? 2 of those. Does that help? You see how it's a puzzle? So, oh, we forgot the 4. We should change that one too. What would that one be? 2 squared. And I have how many of those? Those. So let's figure out our exponents. I have 2 2's, which is 4. And I have 5 2 times, which is 10. You see it, Kayla? And then I have 2 to the 4. Are you Kayla? And then I have 4. I have 2 of those, which is 8. Are we good so far? How many do I have in the numerator? How many 2's do I have? How many total 2's do I have in the numerator? Numerator. 14. And how many do I have in the denominator? Couldn't I just use that subtraction thing now? 2 to the 14 minus 12. It's just 2 squared, which is 4. So this whole thing is 4. All of that is 4. It's just manipulating exponents. Another one? Yeah. You're going to have to wait. You guys, I've handed out like 10 markers today between 2 classes. That's $10. You guys are going to have to wait a second. Okay, can you try that one? All right, let's do this one. I'm going to go a little bit faster. So, first thing I'm going to do is I'm going to distribute. I've got x to the 1/2. I have times 2/3. Then I have y to the 3/2, and I have that to the 2/3. Okay, so now we go from that to 3 over xy over x. The 2's are going to cancel. Let's change the color on it. 2's are going to cancel here. The 2's are going to cancel here. 3's are going to cancel here. That was nice. Now we're left with 1/3 here and just the y. Then the y cancels. What can I do with the x's? Yep. Could I do that? Then what would I do with this? It's actually 3/3. Right? So now 3/3 minus 1/3 is 2/3. Okay? Okay. You guys think you can do this? Another one? I got to get your homework. Let's see, one more challenging one. Look at. I like Ruth. Ruth, I like. You guys are no fun. I have to find these on the internet and try and make this a little interesting. Which one do you want to do? Want to pass the homework? The first one? Yeah, try the first one. Okay, you guys do the first one. I'm going to pass that homework. Okay. So these are different roots. This one's to the 4th and this one's to the 2nd root. So I can't treat them as the same. Right? So I'm just going to turn these into fractional exponents. So my 3 is actually to the negative 3/4. Correct? Sorry, we'll get rid of this. And then my denominator is actually 3 to the negative 1/2. Correct? Then all I have to do is take and, what am I going to do with them, Sina? Swap them. So 1/2 is going to go in the numerator, and this one's going to go in the denominator. Do you see something else I could have done? What? I could have changed that to exactly. I could change it to the same denominator. Watch this, Dina. 3 to the negative 3/4 over 3 to the negative, isn't 1/2 the same as 2/4, Dina? So now which one am I going to move? Which one? I'm going to move this one because then it's going to make this one positive. Does that make sense? So I'm going to actually do this. So it's going to be, nothing's going to be in the numerator anymore. And 3 is going to be turned into positive 3/4 times 3 to the negative 2/4. Follow me? And then this is going to be 1 over 3 to the 1/4. 3/4 minus 2/4 is 1/4. And then that's all I can do. I want, in the very end, I want my exponent to be positive. You want positive exponent. Or it could have been like this. Like that. Make sense? Okay, that's